Welcome back to Getting Started with Linux. I'm your host, Daniel Lowrie. Today's episode, well, we're going to take a look at special permissions. Joining us, as always, Ross Brunson. Ross, we're glad to have you back in the studio.
Thanks, great to be back.
Look at these wonderful special permissions. We looked at regular permissions in the last episode, but the word on the street, yet again, ear to the ground, there are special permissions that we did not cover. Probably a good idea to go over it here. What are these special permissions? How can we work with them?
Well, remember how I told you how simple Linux permissions are compared to Windows?
You made it so easy.
Let me slightly retract that as we talk about something a little more difficult. So what I want to introduce you to is, we talked about the permissions, and I showed you in one of the other videos, I believe it was the last one, how there's a first position or position 0 and then the regular 777, that kind of thing.
Correct.
We're talking about that particular position, and that's where the special permissions live. Now, if we take a look at our slide, let's explain what the special permissions actually are. We use a shortcut or a shorthand called SUID, SGID, and the sticky bit, which is not a shorthand, but it, let's look at STID.
Yeah, it rolls off the tongue. Right?
It sounds terrible. STID, like Stig of the Dump or something like that. So what we do is we look at the set user ID. What that is it mostly allows you to set this permission on something like, say, for example, you want to trust one of your users to be the backup user. Well, in order to be able to do that, they have to be able to run certain programs like tar and things like that as a elevated privilege. Last thing you're going to do, hopefully, is to give them the root user permission. So what you'll do is you'll go ahead and set the SUID bit, which basically allows that user to run that program as if they were the user owner of it, without giving them too many special permissions. It turns out that SUID is also one of the things that when you do a security audit, you look for to make sure that not too many of your programs have been set that way. Okay, so that's the SUID, and that happens to be the numeric value 4 in front of the other 3 bits. So if you look here, you'll see that it says there 4000. The SGID is the set group ID, and what this mostly is for is to make sure that when you have a shared directory that a lot of people are going to be writing files into, that's the thing that allows you to do the cascading of inheritance. So that way everybody at least has to adhere to a particular group when they create files and directories in there. Okay, so that's the numeric of 2 in front of the rest of the permissions. And the last one, the sticky bit, which always makes everybody laugh because they're like, what is that? Sticky bit is basically the save text mode. And back in the old days, when you had very, very little RAM, like under a megabyte, that kind of thing, you were able to set this on a program and it would cause it to be non-swappable. So even if there were other programs, this one would stay in memory. Even if it wasn't used, it would stay there. That meant your load times were, sub-hour, or sub-minute or whatever it was, if you remember the old systems. Okay, so that's the special permissions, and the way that you set those is you typically, some people will not set them, they'll alter them. I recommend altering your permissions for the special bits because otherwise you're going to overwrite, chisel off, and stamp those permissions all over again.
All right, so now we've heard the practicality of this thing. Let's put some legs on it, take it for a walk. How does this work out in real life land?
Okay, well, the way that this works out is, let's go ahead and switch over to our system here. And I have thoughtfully prepared an environment here because this is something that gets asked all the time.
Okay.
Like, great, thanks for telling me the wonderful pie in the sky, PhD dissertation about what special permissions are, but how in the world would I ever use this? So let's take probably one of the best examples would be a shared directory. We talked about that. That's the SGID.
Yes.
And when we use the SGID, we use it as a way of, we actually use the SGID and the sticky bit as a way of forcing it so that people create things a certain way with ownership. And then the sticky bit allows us to keep them from being able to delete anything they don't own. Because think about it, I just set up a shared directory. I made it so everybody can edit everybody else's files if necessary, because it's a shared directory. Somebody gets mad, quits, deletes.
Say goodbye.
Yep. So and then you're into a backup or whatever. Just, it's a terrible circumstance.
The panic button is starting to be hit at this point.
That's right. And Pepsi and pizza are being bought. And nobody goes to sleep for a while.
Yeah.
So let's look at our example here. What I'm going to do is I'm going to quickly make a directory. Now, for those of you doing this at home, you can do what I'm doing. There's a couple pieces of this that I'll warn you is not the standard location for something. So just to make it really understandable, I'm going to make a directory called data off the root of the system. And so you probably put this somewhere else. rather than here, but just for understandability's case. So I make that directory, and then I do a special ls-ld on data, and this shows us the permissions for data. Now, this has just been created, so of course it's owned by the root user as the user owner, and the root group as the group owner. Remember those two things, that there's always a user owner and a group owner of an object when it's created. This is critical to what we're about to do. So for example, because this is set like this, nobody who isn't, no one who is not a member of the root group or the actual root user can create objects or even in some cases get into the directory and do anything.
Okay.
That's very important. So as the owner of this, I'm going to go ahead and chown this. I'm going to keep it as the root being the user owner because that's important. I want to keep control of this. But I'm going to change this over to the users group. And the reason I want to do that is because I have a couple of users who I want to start using this directory. So now you notice that it says users. And that means that anybody who has a primary or secondary, so either in the etc passwd or in the group file, membership and users should be able to get into that directory. Well, guess what? If they don't have the right permission in that directory, they can't create objects.
That would be difficult.
Yes, as in very impossible.
Yes.
Okay, so what we'll do is we'll do a quick chmod, and we'll say, now this is not user, this is group, so G plus W, and then data. Go back up to our ls-ld, and now the group is supposedly ready to write in there. Well, let's go and let's do a couple of things here. The first thing I want to do is give ourselves another open terminal. So we'll kind of drag this around a little bit. So we'll go ahead as rossb. And so now if we run groups, it comes back and says Ross is a member of the group users. Because I see this on the left side of the interface, I know that this is his primary group membership. For example, if I were to run groups against ulogin, you would see that ulogin has a primary group membership, left side, of accounting, and is also a member of the group users. So this is important because both users need to be members of the group that owns that particular object so they can get into it.
Right.
All right, so Ross is going to go over to data, do a quick ls, nothing there. Let's touch a file, file1.rossb. Apparently, it happened, so my ls-l. And you notice that rossb and users. Now,
there it is.
This matches so far because rossb is a primary group member of the users group. He's perfectly set up to create objects in this directory. Now, having said that, let's go ahead and let's get out there and let's go in as good old Ursula login. And now we cd over to data. Actually, let's just go ahead and run groups. Make sure, accounting users. So primary accounting, secondary users. And Ursula should be able to touch a file, file2.ulogin. It works, but there's a problem.
So yeah, it looks like that the group ownership has changed from users to accounting.
Well, remember, it hasn't actually changed. Oh. Because, remember, we've got the users have that primary group, and they have the secondary groups.
That was right.
So if we type groups again on the two users, ulogin and rossb, remember that ulogin has a primary of accounting, a secondary of users, rossb has a primary of users. So if just rossb had gone into the directory and created something, we'd have never really known until the next user went in. So that's very important. Now, there's a way to clear this up. You can notice this as a sysadmin or a system operator and say, hey, Ursula, you really need to fix that. Go in and type this arcane command to change your stuff.
As you do.
As you do, and I'll send you a script and you execute it. Now, if you send your user a script and they execute it, somebody else will send your user a script and they'll execute that as well. So you want to keep them out of that concept. So what we do is we switch back over here as the root user, and let's do a quick ls-ld on that directory to remind ourselves what's going on. So it's set to users as the group owner. Let's make it force group ownership by setting the SGID bit.
Okay.
So as you see, it's set to users, which would normally mean that all you have to do is create objects in there. We know that the two users have different primary groups. So what we're going to do now is we're going to use the chmod command, and we're going to do a G plus S. So that's in the group category or the group ownership, add the special permission, and then we just have to make sure that we do it for the data directory. Now if we do ls minus ld data again, notice there's this funny little thing called an S. The special permission is set. Quick note, there will be times when you're in a hurry and you'll set a special permission, and you will see an uppercase S or an uppercase T. This is an indication, this is the system trying to tell you something, and since it doesn't speak in, real terms, it just gives you an error. A uppercase S means that the underlying X was not set. So you should go back and set that underlying X and maybe have to reset the special bit. Otherwise, it's misconfigured. And so people will say, well, is there any way that I can save that and fix that? Yeah, it's called go back and do it right. Okay, that's how we fix that particular issue. Your mileage may vary otherwise. So now that we have these users, let's kind of drag this down so we can look. Now that we have those users there, at this point, I have set it so that the user, let's see, so it would be Ursula. Let's go to Ursula. And she will go to data. There's already a file in there, Ursula login, accounting. If I do a touch file 3, you log in, you'll see that it's now properly set.
Hey, it's working.
That's right. However, there's one more special bit that we can use here to make life a little easier. As it sits, Ross B can delete Ursula's files and vice versa. The reason why, they're in a shared directory, they both have write on the directory, which means they can change the file that is the directory file.
Yeah.
In this one instance, the special bit of the sticky bit, ST, the 1, is used to guarantee that anybody who doesn't have user ownership of a file can't delete it. They can edit it, they can't delete it. So the way that we would do this is go back as the root user, and we'd say chmod O plus T data. Now, let's clear this and get a better look at it. ls minus ld data. And you will see the S in the second position there, and the T at the very end.
Very good.
That means that they can edit each other's files, but they cannot delete each other's files in case, like, say, Ursula decides, I'm quitting the company, I'm taking all my files with me, issues an RM asterisk in that directory, it'll only take hers out,
it's going to take her stuff.
Won't take anybody else's out.
All right. That's when you get fun with the redirectors, right? And just send nothing into the files.
That's right. Or you set a hard link so they can't really get rid of it. Yes. Okay. So that's the special permissions.
Okay.
And just trying to give some concrete examples of why you might actually use these instead of a kind of a pie in the sky. Here's what they are.
It's helpful. Awesome. Yep. Well, thanks so much for watching. It looks like we now have a little better understanding of these lovely little special permissions that are running around. Every now and then they could come in handy, so having that tool set at your ready is always a good thing. Thanks, Ross, for joining us. Thank you for watching. We'll be back with more. Right now, we're going to call it a day. See you next time.